Hey guys, Mr. Carroll here. I'm going to walk you through how to just learn and use the skill of linearization that you're going to use in our class. So down here, we've got this document open, this Google Docs called Linearization Practice. I'm going to show you one example from it, and then you'll work on the rest of the examples. We're going to be using the program called Graphical Analysis to be able to work with some graph data that starts off nonlinear, and then we are able to make linear through what I'm going to show you with this software. So what you'll do is when you open up after downloading graphical analysis from the Chrome Web Store is hit manual entry, and you can see we got a graph over here on the left that's going to display the data from the data set we have over here on the right. So the first thing I'll do is take my data and enter it manually into the graph over here. So I think maybe we could copy and paste it, and copy and paste it. And so what you can see is we've already got all the data points graphed here. We've got a point all the way over here at 40, and looks like something really small, a 0.1 on the X, and then one over here at 10 and 0.4 on the Y. But what we want to do before we move on is really make sure that we are familiar with what we're working with in the software here. We don't just want to put things in the computer and not think about what we're putting in, like I just did in copy and pasting. We want to label the columns. So if you go to column options here, you can name each of the columns, which our X column is going to be volume. So we can label that V. And the volume has units of meters cubed, so meters to 3. You hit apply. And then we can also change this column, P, for pressure. That has units of pascals, and apply. So now you can also see that here on this axis and here on this axis, we've got the units changed. The directions in the unit Google Doc also ask you to do this, to change your names for your columns in the program. So after you've got that, you'll then, the next step is to look at this graph and then use our, like it says in the direction, the graphical methods cheat sheet. And so what I'll do is open up the Google Classroom. I posted on your Google Classroom, but I'll just take this example Google Classroom and go over to our classroom and take a look at this graphical methods summary cheat sheet. So what this gives us is a few different options of graph shapes. It tells us the written relationship of these things, and then the modification required to linearize graphs. That's what we're going to be looking at. And so if we take a look at the sheet, we can see pretty clearly we've got a graph that looks like this right here, right? So it starts up here and kind of swoops down. And so what we're going to do to linearize it, to make it a straight line, is graph y versus x, or 1 over x. Y versus 1 over x, or x to the negative 1. And so here, if we take our x is going to be volume. If we click more options here and add a calculated column, we have to rename that column, which is going to be renamed 1 over velocity, or sorry, 1 over volume, because that's what we're working with. And then the units are going to be 1 over meters cubed. The next thing you'll do is hit Insert Expression. And we want to hit the expression a over x, where our a is going to become our v. And then click Apply. Once you do that, you can see pretty magical here. We end up taking all those data points that were curved and end up with a very straight, looks like a very linear line here. And that's really helpful for us because when we work with writing equations for this, it's much more simple to work with just a simple y equals mx plus b style equation and plug in these values we have on our axes for our y and for our x to be able to write out the written relationship in a mathematical form. And so now what you'll do is click this icon down here that gives us a few options. One is to apply a curve fit. Well, we don't have a curve anymore, we just have a straight line. Once we hit apply, it already knows that linear is probably the best one to use. If you hit apply, you get a box over here, and it tells us the form y equals mx plus b is the equation you would use to write out the equation, where m, our slope, is 4, and b, our y-intercept, is 0. So we're going to grab those two pieces of information and make sure that we put it over in our document over here. And so we can come down to the mathematical expression area, and we'll put in the equation in the form y equals mx plus b, where our y was P for pressure, so P equals our slope, which was 3. So if you look back at this, it was, it was 4. And the units would be Pascal over 1 over meter cubed. And it's fine if you leave it like that for now. If we simplified it, if division's multiplying by the reciprocal, it would just be Pascal times a meter cubed, right? So meter cubed. Next, we're going to multiply it by, or just put in parentheses, 1 over v, because that is our units on the horizontal axis. And then plus 0, we'll go ahead and add the 0 in, and the units for our y-axis are pascals. So what this gives us is really powerful, actually, right? So we started off, and you can change these axes pretty easily. I can just change it back to what we had in the beginning. So you started off with something that was curved, right? But now what we have is a written equation that allows us to be able to take any given volume, put it in this equation, and find out the given pressure. And you can even try that. I encourage you to try that and see and make sure it works. The only thing I didn't show you how to do right here that's required for the assignment is I want a screenshot of your original graph and then a screenshot of the linearized graph, making sure that you have axes labeled with symbols and units, which you can do pretty simply in this program right here. All right, so that's the assignment on linearization practice. You'll work through this first one on your own, and then through the next data set and so on, using this to give you a guide as to how to linearize each of these graphs and come up with the equations that go along with them. Thanks.